Hello, my name is Ricardo Romero, and today we're going to talk about the hydrocarbons, alkanes, alkenes, and alkynes. My partner is Said Morales. Let's start. What are hydrocarbons? Hydrocarbons are a group of organic compounds that contain mainly carbon and hydrogen. What are alkanes, alkenes, and alkynes? Alkanes, alkenes, and alkynes are a functional group of aliphatic molecules, open chains that do not form rings. These are characterized by only contain carbon and hydrogen atoms in their molecular structure. The, di- the difference between saturated hydrocarbons and unsaturated hydrocarbons contain only carbon and carbon single bond, and the second contain carbon, carbon, double or triple bond, more hydrogen can be added. Remember that alkanes are a single bond, alkanes a double bond, and alkynes are a triple bond. To name and specify the number of carbon atoms in organic compounds, prefixes are used. I will mention them below. In the picture, you can see the number of carbon atoms and the prefix that we use. Then we put the letter A to facilitate the pronunciation and D, tri or tetra. Remember that Remember that the root is permanent, however, the suffix changes depending on when it's in is a horizontal line, with this in a two horizontal line, and with this in a three horizontal line. Then you can see in the picture the formula and the name between alkane, alkene, and alkyne. An additional in organic chemistry, as a cyclic compound is a cyclic compound in which a series of carbon atoms are connected to form a bond or ring. The cyclic structure has the name of cyclone. Rules. Always start at the point that is closest to the link's single, double, and triple bond. The additional groups are named the same with the prefix according to their carbon atoms. Additional groups always go first, and we repeat use D, tri, or tetra. Structure. First, the additional group, then we count the carbon atoms. We place the prefix according to the carbon atoms, hence the vowel A. To facilitate pronunciation, we count how many bonds there are and place. D for 2, 3 for 3, tetra for 4. And finally, according to the link, we place the suffix "ein" with this 1, "in" with this 2, and "ein" with this 3.
In the alkane example, we can recognize the alkanes with determination A and E, like the methane and ethane. In the last exercise, we need to count the carbon atoms, specifically 5 carbon atoms who makes a pattern for left to right. An additional group, the 2 hydrogen atoms CH3 are dimethyl and combined with the pattern forms 2.3 dimethyl pentane.
In our key example, first we count the carbon atoms, that is 1, 2, 3, 4, and 5. Then start from the point closer to the link always. Because it's 5 is pentane, and use the suffix in pentane, and is to the link always, entonces is 2 pentane. The next, we count 1, 2, 3, 4, 5, and 6. Because it's 6, we use the prefix X and then the suffix in. And the letter, the number 3. Then we count the additional the additional that is in the number 2 is methyl. That is 2-methyl 3-hexane. Then we count the carbon atoms. That is 1, 2, 3, 4, 5, and 6. Because has 2 double bonds, is we use the D and then the suffix in. So the result is hexadiene. That is in the number 1 and 3. In the and then methyl, that is in the number 5. So the result is 5-methyl 1,1,3-hexadiene. And finally, the alkenes example. We count the carbon atoms, that is 1, 2, 3, and 4. That is 4, and because it's 4, we use the prefix but and the suffix in. The triple bond is in the first, and is the number 1, is 1-butene. Then in the additional is the methyl, that is in the number 3. The another exercise, we count the carbon atoms, that is 1, 2, 3, and 4. Because it's, or sorry, it's 5. 1, 2, 3, 4, and 5. Because it's 5, we use the prefix pent and the suffix in. And the same, the triple bond is in the number 1. Then the methyl is in the letter 4, is in the number 4. And the result is 4-methyl 1-pentene. And the last one, we count the carbon atoms. That is 1, 2, 3, 4, 5, 6, 7, and 8. Because it's 8, we use the prefix oct and the suffix in. That is octane. And this is the letter 4 in the number 4. 1, 2, 3, and 4. Then we count the methyl, that is in the number 6. And then the number ethyl, because are 2, is in the number 3. The result is 3-ethyl 6-methyl 4-octane. Thanks for your attention.